Hi, and welcome to my YouTube channel. So today I'll be taking you through creating a portfolio project with R. Yeah, so we'll be doing an analysis of a certain data set that we have for pizza sales. We do analysis, manipulation, and also the visualization of that same data. All right, so I'm going to create a new file. I'll use our notebook so that I can be running in chunks. Yeah. So I delete this section of this one here that I don't need. Cut. Okay, but you can as well use the R script. Yeah. I just find this one a bit easier. So today we'll be doing a project for pizza sales. So to show you how my file looks like, so this is the CSV file that I have. So when you open it, now I think I prefer to open it with Notepad. So you can see this is the data that we have. It doesn't look very readable, but we're now going to import it to R, yeah, and manipulate it. So I'll say, so how do we import data in R? Okay, so there is a, we use a library called readr, and so we say library, and there, library readr. Then you click this one, it says run current chunk. Now it means that it has loaded that library. Now we can import the file. So I'm going to store it in a data frame called df, and I'm sure we know that this is how you name a variable. So during that file read.csv, since that is CSV file, and what's the name of that file? So that I don't confuse the name, I'll just come and take that name from there and run it. It says cannot open file, no such file or directory. So it means that my working directory is not there. How do you get the working directory? Get working directory. You can see it's OneDrive documents, but my file is in desktop pizza. So I have to change that to working directory. So how do you do that? I come to session. I say set working directory, choose directory, and it's on the desktop pizza. It's there. So if I load this file again, it will load, all right? So you see there is no error at this point. So I can click df to view that data. But so this is a data here. But so that it appears nicely, you can use view df. You can see now the data will come in form of a table. All right. And to analyze this data, we can see that it has pizza ID order, it has pizza name, order date, the date it was ordered, the quantity, if you bought 1, 2, like that, and then the time it was ordered, then the unit price. Unit price, it means the price of one single unit, and then the total price is the total price. For example, if it's a unit is 13.25 and you say the quantity was 2, so it will be 13.25 times 2, that will be the total price. Okay. And then there's a pizza size, there's medium, there's large, you know. And then category, there's a classic pizza, there's a veggie pizza, there's a supreme, then the ingredients of the pizza and the pizza's name. So since we have that data, what are the questions that you'll be answering today? So the questions that we'll be answering today will be so these are the questions. All right. So the first question is, what is the total revenue? So from this data that we have, what amount did they collect for all the pizzas? All right. So, and you can see this column of total price. So it's getting the sum of everything on this column. So, and how do we get sum in R? So here I'm going to create another chunk. You can select this. Yes, so we create a chunk here. I'll say to get sum, we say sum of, so we have the data frame is DF and the column is pizza total price. Run that, we'll get the total revenue collected. So I can just write here total revenue collected. And so to make my work easier, I think I can put it in on a variable which I've got, so I'll name is total rev. Then when you do that, you will not see anything. Now you have to call that variable so as to see the amount, the value of that variable. So the amount that was collected is 817,860. Okay, so the next question is the average order value. Okay, here. So so I create another chunk here. How do I get the average order value? How do you get the average? Average is the total divided by the total price over value is, the value, the total price, and then divide by the number of orders. So already we have the total price, but then the question is, how do we get the number of orders? Okay, so first, as we can see here, the orders, we can see here we have order ID. All right, so like here we have 1, and then order ID 2222 has been repeated, meaning for this second order it was purchased this classic, the 5 cheese, but again this is still one order. As much as it has been repeated, it's still one order. So to get the total number of orders, you have to get the distinct values. Like if it's 2, I don't get the 5 of them, I just get 1 as one order. If it's 3, this is one order 3. Okay, so how do I get the number of orders? So I'm going to create a variable. I call it number of orders. Sorry, just here outside, I'll call it number of orders. How do I get it? So in R we can use the n distinct. But so what am I getting the distinct for? The column code order ID. This order ID. So how do I get this DF? And then to get that, use the $sign. And then order ID. So you get I could not find the function and distinct. So in data manipulation, we normally use a library called dplyr, but I normally use a library called tidyverse because it has all of those packages. I'll show you how. So if you say library tidyverse, when I run it, you'll see here the number. It has attached how many packages: dplyr, focus, ggplot for visualization, the one that has bar charts, line charts, library date for date. Yeah, so when I run this one, it will now give me could not find. Okay, and distinct. Sorry, I just missed the spelling. And distinct. Does I have to run that variable? So I'll get that we have how many orders? 21,350. But our question was the average. The average what? The average order value. So I'll say the total number, the total price, which is the sum, which is total revenue. Instead of repeating this whole thing, I'll just take this variable. Okay, so I'll call it avg AVG average order. So it will be the total, which is total rev, divided by total number of orders given by the number of orders. So to view the answer, we have to call. Okay, so you can highlight it, then run that part only. So, and you can see now the average is 38.307. Okay, so that's the average order value. Okay, so what's our next question? The next question is total pizzas sold. Can copy this. Total pizza sold. So total pizza sold is the quantity. Like now we are out not the value, not the amount. It's the number of pizzas that were sold, and this is gotten from this column quantities. You can see here one pizza was sold. One, okay, as you go like that, you'll see there was where there was two pizzas, you know, three, yeah, something like that. So to get the total pizza sold, so total pizza sold, it's call it total pizza sold, call it like that, and then I'll say it's sum of GTDF over the sum of that column of GT. So to get it, to see what's the value of the total pizza sold, I'll get it 49,574. That is the total pizza sold. The number of pizzas 49,574. Then another question was total orders, the total number of orders placed. I think this one we are done when we are calculating the distinct, like that. Total orders, the total number of orders, which you should do here as the distinct, which was n orders. Since we had already assigned it to a variable, just call it that was 21,350. The next question is the average pizza per order. The average pizza per order. Average pizza per order. So how do you get that? So there were 49,574 pizzas. So how likely is the number of pizzas, like per order? How many number of pizzas were there? So how do you do it? You take the number of pizzas, divide by the number of orders. So it's simple. We had already calculated the number of pizzas, which we call it total pizza. So AVG pizza to the total pizza. Sorry. Divided by the total number of orders. And again, there are many ways to kill a rat or a cat. So whichever way you can try to get these formulas I'm doing with other formulas. Okay, yeah. So like for example, in sum, you could have used the summarize function. The summarize function is the one that is used in R to calculate math, like sum, count, you know, mean, standard deviation. Yeah, you can use it as well to calculate the sum, but you'll know the answer will be in form of a data frame. So like when you want to calculate the average, you have to convert, like if you were to use it here, you have to convert that data frame now to a numeric using the maybe as the numeric function. So they are particular right here for all these formulas actually. So that's the first part of the questions. The next one now is there is getting the data and visualization as well. So you can see there's bar chart, using line charts like that. So the first question is the daily trend for total orders. So what's the daily trend for total orders? I'll explain that in a few. So what does this mean? So it means that daily trend, daily is every day. Like if it's on a Monday, for this whole data set, as you can see, it's for the whole of 2015 from 01. This is date 1st of January. You'll see it's till the end. So for 1 year, from January to December of 2015, how many orders were they per day? Like if it's on a Monday, how many orders were they? Tuesday, how many orders were they? But now, as you can see from this data set, you don't have the day. We just have the date. So we have to convert this date to today. Okay. Today. So how do we get this? And again, also there will be. Let me see these questions here. Daily trend, hourly trend. So like this hourly, we have the time. Let's say it's 13:34. So this is our 13 at 1 p.m. We just only need to get this. Okay, so I think we can get the two of them, which I'm sure we'll get that there. How to get the weekdays, the daily, and the hourly trend. Okay, so the first thing, even before we go to the daily trend, I have to create now a column on this DF that caters for the weekday. So at here it shows for this row which day is it, Monday, Tuesday, and what the hour it is. So, and again here the many ways to kill a rat. You can use the functions or you can subset from that. So for me to get the weekday first, I'll say df. Here now I'm creating a new column, okay, in that data frame called weekday. So I'll say weekdays, then dmy, date month here, and then which column am I converting? It's the border date. So it has created. So if I run my data set again, you'll see that it has created a column here called weekday. See, this is on a Thursday. No, these all were for 1st of January, 2015. All of that was Thursdays ago, and it's Friday. So that's how you get the weekday. And again, so that I can finish with the columns, I can have another column for time. Now here we can use the same as that formula, but I can also use a formula for subsetting. Okay, string subset. How does this work? So I'll take this column order time, and then I'm taking the first and the second value, like 13, 14. So I will take from, so string subset in R takes from, you say from position 1 to position 2. Where that I say string subset. What am I subsetting? My column at order time. Then I'm subsetting from the first number to the second number. Okay. So when I come to my data again, I'll say that there is time. So like the first one is 11. Then you go for this one, you'll see that the value is 12, like that. Okay, so having those columns, now we can create we can see now the daily trend, like weekdays, Monday, Tuesday, how many sales are there. So, we can say, I like to use variables. I call it daily orders. How do I get it? I take that old data frame. Here we use the pipe operator. And then again, we remember, as we said, for this data frame, the idea has been repeated for all these columns. So we have to get the distinct so that we get the number of orders, okay? So, but before that, we have the old data for the year. So we have to group it by the weekdays. So if we say group by weekdays, let me write here so that you understand. Group by weekdays. How did I call my column? Weekday. If I say group by, now it will divide my data into Mondays, Tuesdays, Wednesdays to get this. All the orders on Monday, all the orders on Tuesday. Okay. Yeah. So group by, and now again, what we are counting, we want to get the number of orders. So that is it's like counting the number of orders in a particular day. Okay. Pipe operator again, and then distinct. So as I was explaining, order ID, and also note that we're using the pipe operator, since we are calling this data frame df, I don't need to write df $, weekday df $ order ID. So we just call the column directly. So, and again, as I told you, I've said about the summarize function, it gets the mathematical functions, okay? So here we want to count the total number of orders. So I can just call it count or total. This is the name of the column. And then n gets the totals, okay? So we run that. Okay, but so that it can appear nicely. So as you can see, on Friday there were those number of orders. Monday, that it can appear nicely. There's a library called data table. I can load it here. Library, call it dt. Sorry, dt. Okay. So when I use here dt, I can call it data table, and then I say for the daily order, which will appear nicely here. So as you can see, there it is. It shows you on Friday how many orders were there, on Monday how many orders were there, like that. But and again here you can group by, you can say we order by count, or from the smallest is from the largest going forward. From the smallest you can use that. Okay, and also for the weekday you can arrange like that. Okay, but now apart from getting the daily trend, so that's the trend, that's how it looks like. But now our question was also asking about the bar chart. So I'm going to draw a bar chart here as well after this. So I'm going to use ggplot to draw that bar chart. So how do we draw a bar chart in R? So let's say ggplot. It takes the data frame we are using. So now we are using this data frame that has the daily. So this is what we'll be using as our data, not the whole data frame. After this, here it has the x and the y axis. So yes, okay, here you can write x to y is equals to, but it's not, R will understand if you write here weekday. It will understand weekday is on the x axis, and then count is on the y axis. And then plus, since it's a bar chart, I'll use geombar. Then start equals to identity. So in that how it will look like. We'll tell you the sales on Friday, the sale on Monday, the sale on Saturday, the sale on Sunday. Yeah, something like that. And also again, so that maybe it can have colors here, I'll say for aesthetics, I'll say fill is equals to weekday. So you'll see that it shows you something nicely, and also here there's a legend that shows you what this stands for, Monday, Tuesday, yeah, like that. And also another thing we'd want to note that is to get, for example, this has not been arranged, Friday, Monday, but I would like it to appear from Sunday, Monday, Tuesday, Wednesday. So how do we sort that? So we have to write weekday as a factor, okay? You have to convert it to a factor. How do you convert it to a factor? Since you have that column already, all you can modify it by writing factor df weekday, then levels supposed to say right now Sunday, Monday, Tuesday, Wednesday, Thursday, Thursday, Friday, okay. Run this first. Okay, so when I run this df weekday, I can try to run here on the console. Okay, I could have written a unique. So it has been grouped to Sunday, Monday, Tuesday, Wednesday, Thursday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, it has been grouped like that. So now we can run again now with when it has been grouped. Okay, it has not yet grouped, yeah, because daily orders, it still runs with the weekday that has not been. We have not rerun this one after the weekday has been turned into levels. Run this again. It will have rearranged now from Sunday, Monday, Tuesday, Wednesday. So to rearrange, you have to group it as a factor. So the next question was hourly trend for orders. So I can create another chunk here. Hourly trend for orders. So as you can note, we have already created that column for time. Here, time, and from our data set, we can see we saw just created that 11, 12, So it's asking hourly trend for orders, like through that period of that data set. How many orders were placed at 11 a.m.? How many orders were placed at 12, till the end, like that. So again, here we're counting the total, the count, So again, we're going to use the summarize function. Yeah, maybe you can even try and pause the video and try whether you can do it fast. So I create a variable here. Hourly order. So here I'm grouping. Here we group with weekday, so to get Sunday it groups by weekday, but here we're going to group by time, by 11, 12. Look at that column, we call it time. And then again I say distinct, so it doesn't give you the duplicates. So here distinct order ID. Then now we get the count, the total number of orders. The summarize function in R. So you can call it total. The other place I named it count, you can call it total. Again, we can use our data table so it appears nicely. I just want it to appear just good enough that you can just call it directly. But I want it to appear beautifully. So So when I call it like that, you can see at 9 there was one order, at 10 8 orders, at 11 12 31 orders, at 12 up to the time that was recorded 18. How many? Okay, so this is page 1. You see these are 10 entries, but they're 15. When you go to page 2, there was time still there, 23. This is 24 hour clock system. I think that's what it's called, like 9 a.m. And this one is 7 at night, 8, going like that. Yeah, and also again, we need to do a bar graph or a bar chart. So again, I'm going to use here ggplot tool. So how do you ggplot the data? The data we are using here is hourly orders, then what's our x, what our y? Our x is time, our y is a total, and then plus geomber. I don't know whether it's good to copy the other one, but let me just type. I think it's best when you type, you understand. Start is equals to identity. Identity. There's it correctly. Identity. Where's identity written? Identity. Oh, sorry. I'm pronouncing it from anyway. It's fine. Okay, so that's how the budget looks. Again, if you want to say the legend and the colors, what do we use? We use fill. So fill is equals to, and fill with the totals, or no, can fill the time as well. Yeah, so you can see 9 1 order like that. So that's how our budget looks like. And again, this question also had a line chart. So this is a bar graph. So how do we draw a line chart? How do we draw it? It's still the same thing, ggplot, almost similar. The data itself, the data set, which is hourly orders, and then this is the x-axis, the y-axis, and now in there you have to group for the line chart is equals to 1. Now instead of geom bar, you use geom line. Yeah, so that's how the bar looks like. It shows there the sales that increased up to this time, 12, 1 here, and then also they increased like from 6 at this time here, from 6 p.m. here. There are quite many. Yeah. So from even here we can conclude that actually here Friday has the highest sales. You can write your conclusion here. Friday has the highest sales. Okay, so and from our time here, what can we conclude? We have drawn a bar chart first here. Bar chart to run this part. You can see that our highest sales are at 12 and 1 p.m. Okay, and also again from 5 p.m. here, 5 6 7 there. The sales are also good. So you can conclude that as well. Here 12 to 1 p.m. and 5 p.m. to 7 p.m. 7 You see, as we go towards the day, as we go towards 10, 11, the sales reduce. Take a cup of water for you. Yeah. So here we have a bar graph, bar chart, in the line chart here as well. Here the color is too black. I can add color. I said can use color, but should choose a better color. Can I use blue maybe? No, and that line will be color blue. So our next question was the percentage of sales by pizza category with a pie chart. So here, so as you remember, if you can remember from our data set here, we said the category of pizza, there's a classic, there's a veggie, there's a supreme. So you divide by category. And now the question is the sales, like if it's classic, what is the total price for the classic? If it's veggie, the price. But also apart from the price, it's asking for the percentage of the sales. You know, like if it's for classic, it's 10,000. The total price was 40,000. So times 100, the percentage, okay? Yeah. So how do we get that? So I can call my variable sales category. Okay, now I'm taking from DF. I'm going to group now. You see the other one you have grouped by time, by day. So here I'm going to group by category, pizza category. Okay. And then again here we are finding but here we are finding the sales. Sales is the price, the total price. Again, I said in R to use this mathematical, like calculating the sum, the count, use the summarize function. That column total is equals to, what do you get? Sum is the sum of the total. This is the column that has the price. So here we just get the total, not the percentage. So what I'm going to do, I'm going to create another column that now has a ratio. So you add another column by using a mutate function in R. I'll call it ratio. Say is equals to total. So this total that I've gotten here over now total is total per, this as total is per category, like 10,000. Classic is 10, 20, and like that. Total per each, but also I want the sum of the total so that it get a percentage, And then sum of total, and then times 100. That will get me the ratio. Can try to run this and see what we'll get. As usual, I use a data table. Category. So you can see here it's giving us the total, as I explained, like chicken, it's a total of 195,000. This is as 220. This is what we call total. So to get the percentage, I said this total over the sum of now the total. Okay, times 100. And again, you see this is two. This number of decimal places, there are too many. I can use the round off function that gets the round. So I'll cut this one here. I'll say round. So how do we do round? So X will say round. Okay. I return that, and now I want it to round off to. I take that as the data and then to 2 decimal places. So when I run this one, it will give me to 2 decimal places. And again here I wanted the ratio. I did not want the total. So I can also use add a select function that only selects what I want. Now, but here instead of selecting pizza category and ratio, the easiest is to remove the total column. So here I say minus total. You see, we'll only get the category and the ratio. Then now the question needed a pie chart, sorry, as well. Chart. How do we draw a pie chart? And again, I'm going to use the ggplot pie chart. So ggplot. So again, this is the data variable that I'm going to use because I'm calculating for the category. A pie chart, the value of x is blank, and then the y, you want the ratio. You know, ratio, and then plus. Again, here in pie chart, we use geombra, but we'll add a coordinate called polar here. So start again. Store identity. I hope I don't misspell this one again. Identity here. You remember in the line chart we use group. Here we use width is equals to 1 plus here we'll say theta. That's how it's written. Y. Then start is equals to this and see how our pie chart looks like. Theta is equals to y, start is equals to 0. Unused argument. I go from the season. Okay. Now let me try identify my mistake here. Pizza. The color. Start. Oh, it's written as start. Sorry. Yeah, so you can see how bad it looks here. Now you can add the fill. It's equals to have to fill by factor. Keeping by pizza category. Yeah, so this is how it looks. It tells you that this is chicken, this is classic, this is supreme, this is veggie. But I would also like to, inside here, it gives me like the percentages. Yeah, I tried that. I'll give it chicken. It was percentage of 23.96. I can just copy here. This other side. You know, yeah. So how do you do that? Use something called geom text. Okay. Then we say label. It's labeling with ratio. What does it look like? You see the way they are stacked up together. You can use a label is equals to ratio. Yeah. Right position is equals to position stack. Position. I'm writing the correct position stack, and then it's going to slant it by 0.5. So it looks like that. So can we confirm this is chicken? This color is 23.96. The blue part is veggie 23.68. Classic 26.91. The green one. So our pie chart is good to go. Okay. What was our next question? Percentage of sales by pizza sizes. Here we got by category of classic, but sizes we have large, small. We're going now to get the percentage of sales by sizes. So it's actually the same thing. We just replace category with size, so that we don't be lazy, so that we understand. And it takes more. We write it. So pizza sizes. Again, instead of picking by category, picking by size. Pizza size. Size and summarize function. I create another column by mutate function called percentage, which is again, as I showed you, the middle of rounding off. The data we are doing is total over sum of total. So you have the round function to two decimal places. And then we select, okay, before the select, can do with that. Then data table. That's how it looks like. Large 45% with that total, but we do not want the total column, so I'm going to slash it out with the select function. So select minus total. And that again, calculate the percentage. It will now have the size and the percentage only. So you see the large is one that was bought most at 45.89%, followed by medium at 30.49%. Yeah. So, and also the percentage of sales by size also needed a pie chart as well, which you have covered from the category. So this will be easier. So here the plot data read yes as x and y. In a pie chart, x is blank, y will have the percentage now. Okay, and then plus number equals to identity. So here is a pie chart. We have to use width is equals to 1 plus code folder equals to y and start don't equals to 0. That's how it looks. And so we said you have to use the fill function for the fill here, and try without using the factor. You see how it looks like. You have to use a factor here. Pizza. Okay, and here we go. Large this percentage again. We said we need the data labels using the June text. Okay. Run is equals to position stack. We just equals to 0.5. And so if we don't use this one, the data will come. Can try running here. See how it looks like that, you know, it's not that neatly arranged that you have to use this position stack with just of 0.5. So when I run this, sorted label, when we ran up to here it was fine. So our problem is here, geom text label is equals to pct, that was our column here. Say pct, so label is equals to pct. Sorry, here one. Okay. Yeah, looks a bit better. And you can compare. You can see large is this reddish 45.89, medium 30.49. So this is correct. Okay, so we're almost done. The total number of pizzas sold by category, and also use a funnel chart. Get another chunk. This is number, not this. So this is just purely count the total number of pizzas sold by category. So we get so variable total pizzas like that. NDF, our pipe operator. We are grouping by category, group by pizza category. And summarize. So here we're getting the total. So just from the quantity, we say that it's the one that has the total. So quantity to the column. Okay. And then again from my good looking data table, I'll call it that variable. So and yeah, let's choose this. A chicken has a total of 11,000 plus it like that. So The next thing was to draw a funnel chart. A funnel chart. So do a library called High Charter. Library High Charter. And by the way, if you call a library and it says it has not been found or something, it means you've not installed. So you have to do a install dot packages and then the name of the library here, High Charter for the funnel chart. Okay, and when you do that, you can load the library and it will be good. So we are doing a funnel chart for this variable for the total number of pizzas. How do you do it to say H chart? So X will have the pizza category, x-axis, and then the Y will have the total. Name is equals to fruits. Let me run it. This is how our funnel chart looks like. We can see chicken 11,050, classic 14,888, supreme. No, like that. That's how our funnel chart looks like. Okay. The second last question, the top 5 best pizzas sold. Top best 5 pizzas sold. So in rating, which were most bought, which were in top 5. So I create another chunk here. Okay. 5 best sellers. Put it as a comment here inside. Okay. So will I call it? I can call it the best sellers. Best sellers. So we are grouping by. So since we want to know the the pizzas are sold the best, so we are doing by pizza name. Let's see if there is a 5 cheese Italian. Which one sold the highest? Okay. So now we're grouping by that column, which is the pizza name. So pizza name. Then again, I told you the summarize function does the mathematics, the add, the everything. So I'll call it total sold. Then quantity, like how many were sold. Okay. Quantity. We need to see this. So that variable, I can use see what it has. So as you can see, this one has 32 rows. You can see the barbecue pizza is full 34, that 22, big meat. You see, it showed all of them. And again, it has not been arranged. Okay, so that I arrange from the best selling, I use the arrange function in R. So the arrange function looks like this, arrange. Then descending, we are arranging by the total number of these pizzas sold. Okay, so when I call it like that, you can see now it has arranged from 24, 53, 24, 32, like that. But now my question is asking the top 5 bestsellers. So you have to take the top 5. How do you do that? We use the head function. Head, and it's taking 5. And then here, let's use a data table. Best selling pizzas. And again, now the worst selling, it will be the same thing. So here, let's call the bottom 5 worst. Okay, so it will be the same thing. I'll create a chunk. I'll call my variable pizza was or something, just give a descriptive name for variable. Maybe mine is not very good, but I can create just. So here we're grouping again by pizza name. Then summarize, we said for mathematics, addition, everything. I'll call it total. Can call it again pizza sold. What column quantity? Okay, again rearrange. Remember it had so we use descending if you want to. Okay, by default it arranges ascending from the smallest to the largest. When you see descending, it arranges from the largest to the smallest. But since I want from the smallest, I will not use the descending, so it will arrange by ascending automatically. So I call my data table for that variable. That's this one. Larger, the smallest for 90. You see the last one has the highest. But again, I want the bottom 5. So I'll take 5 as an head. I'll get from 90, 934, 937. So we've answered all of our questions. Yeah. So please like the video. Yeah, like, subscribe, share, comment. Give a heads up if you have a question, ask on the comment section. Yeah, see you on the other art project. Thank you.